Okay, guys, in this video lesson, we're going to start talking about heat transfer. All right, we know from our last video lesson that heat always transfers from hot to cold when they come into contact, but there's different ways this happens. All right, so there are three primary ways that we can look at heat transfer. One is through conduction, the second is through convection, and the third one is through radiation. All right, so basic definitions of each one. Conduction results from the atomic collisions between vibrating particles. Okay. Keep in mind that when you have conduction, the substance itself does not change location, so it can still be done statically, which means this can happen through solids, liquids, or gases. Okay? Convection results from particle movement from the source of heat. So in this case, the actual particles themselves move or they flow away from the source of heat to cooler areas. Okay? So because they have to flow, they must be either in their fluid or gaseous state. So solids can't really do this. And then finally we have radiation. Radiation is actually a little different because when radiation, we actually have a bombardment of photons from electromagnetic energy into a substance. All right. Little graphic over here kind of gives us an idea of the three things put together. So inside a pan of boiling water, you're going to get convection where the hot comes from the bottom and the water is going to roll. You ever heard of a rolling boil? That's why you get it. Okay. Conduction comes through the pan into the handle. And then any heat given off of the flame, that is electromagnetic energy. Okay, it's thermal energy. It could be, some type of heat. So that's our radiation. Now, this animation does a really good job of showing this stuff. So we're going to pull this thing up and use this to help us out. Okay. And here's our three different types. We have conduction, convection, and radiation. All right. So we look at conduction first, and even if you have a solid, inside solids, particles are vibrating in place. They're not stationary, okay? Solids have movement. They just don't get to flow away from each other. If we put heat to this, what's going to happen is these particles are going to start vibrating more violently. And they're going to bounce into these particles, which causes them to vibrate more, which is going to bounce into these and bounce into these and bounce into these. So what happens is through time, because of these vibrations hitting each other, they transfer the kinetic energy through these, and they transfer that thermal energy down the line. This is called conduction. Okay. Now convection, similar idea, except in this case we have a fluid. So as you start to heat that fluid, they get more energy and they start to roll, or they start to move. So this particle moves its way up and it cools down, and then it gets pulled back in because of this constant motion or this convection. Okay, some of you guys might have convection ovens at home, and what a convection oven basically is, it's a normal oven that has a heating coil, but they actually use a fan or they use a system to get the air to move. That circulating air creates a better even heat and has a different baking experience for people who use them. Now, radiation is our third one. It's a little different. If you have a substance that's sitting here and you bombard it with energy, it can be UV light, it can be the sun, it can be energy off of a fire. As long as you're not coming in contact with it, this UV light, or this, I shouldn't say UV, this electromagnetic energy coming from any type of energy, as this energy comes in, there's energy waves hitting it, and those energy waves cause these things to vibrate, okay, and they vibrate and they warm up. All right. So those are our three different types of energies that we get when we're looking at how we transfer heat. Now, of the three, the one that we're going to focus on the most is thermal conduction. Okay. Convection works also, radiation fine too, but in our kind of unit here, we're going to focus on the conduction side of this. All right. So in focusing on that, what we want to take a look at is what things conduct very well and what things conduct poorly. All right. Here we have an image of basically it looks like a torch of some sort melting a block of ice with some sort of boat of some sort. I'm not really sure where this image came from, to be honest with you. Anyway, it looks cool. This idea of thermal conduction centers around the idea of the ability to transfer heat energy through contact. Okay. Now, metals are really good at conducting. Okay. Nonmetals tend to be poor at conducting. All right. We also often call that metals thermal conductors, and we often call nonmetals thermal insulators. All right. So think of like, aluminum pan or those kind of things that we use for cooking. They're made of metal because we want the heat to transfer quickly from the burner, from the oven, through the pan and into the food that we're trying to cook. So we want good conduction there. All right. Think of things that are good insulators, like Yeti coolers or any type of cooler. Actually, they're usually made of some sort of non-metal, either a plastic or a foam of some sort that is not good at conducting. All right. So they're trying to actually limit that conduction. Okay, so the reason why metals are good at conducting electricity and non-metals are not, it comes to do with how they actually bond together when they're alone. Okay, so metals form kind of a metallic crystalline structure, and inside that structure, you have your nucleus of every atom, but then you have a lot of electrons. And because of metals and how they overlap each other, they actually have these things called conduction bands, or areas that there's overlapping electron orbitals. Now, gets into chemistry a little bit here, but what happens is the ultimate thing here is that electrons are much easier to move and flow through a metal than they are for nonmetals. So as a result, because the electrons can flow, if you heat up one side, those electrons gain energy. They can travel through the entire metal, carrying that energy with them, and they can bump into other electrons, which then cause them to gain energy, and it can travel and kind of roll down through the metal much easier. Nonmetals don't have this conduction band. They don't have this free moving electrons inside them. Okay? As a result, when you put heat to a nonmetal, the electrons around it stay and they don't move. So you can heat it up, but there isn't a good movement of energy through that nonmetal. Okay? Take home here is that metals are really good at conducting. Nonmetals tend to be poor at it. The reason why is because metals have a conduction band of electrons that are allowed to flow better through the metals. Okay? Because of this, we can start looking at metals and kind of how they conduct really well. Okay? It'll also play a role later on in our year when we start talking about conducting electricity because it's for a pretty similar mechanism. All right, we're going to end the video lesson here. In the next one, we'll talk about thermal expansion.